Isaac Bahler.
I'm Samantha Chong.
I'm Nanya Anyaduba.
And I'm Nier.
And welcome to the correlation between economic status and the quality of education. Before we start, here is some relevant background information. When we say equity in education, we tend to mean one thing, such as fairness. Equity is commonly interpreted as treating every student the same, such as giving them the same exam or teaching them at the same pace. But equity actually means ensuring every student has the support they need to be successful to increase their chances of achieving an equal outcome. Equity in education requires creating systems to make sure each child has an equal likelihood of success. In our analysis, we wanted to investigate the role that economic status plays in a child's education. Over the past decade, the financial gap has widened between Canadian families. Academic outcomes are one of the many key areas influenced by family incomes. Adolescents from low-income families usually begin school initially behind their peers who come from affluent families, as shown in measures of school readiness. A study done in Montreal, Quebec by the Institute of Research and Public Policy showed that even as early as the third grade, there is a distinct difference between children depending on their higher or lower socioeconomic status. Generally, wealthier students were scoring higher on standardized tests. A report by Armin Yalnizyan studies the financial gap that has been increasing and its implication. Ms. Yalnizyan not only talks in a general sense, but also how it manifests socially, and more importantly, in the next generation, commonly in their education. To begin, let me briefly outline the aim of this report to you. In the interest of remaining on topic, here outlined are our primary and secondary objectives. We aim to determine whether or not there's a statistically significant link between economic factors and educational quality. Should this be the case, what does this trend demonstrate to us? Our secondary objective is the proposal of a solution in order to correct this lack of equity should it be determined to exist. Relevant to this is the null hypothesis and the alternate hypothesis, which can be shown here. We will be attempting to disprove the null hypothesis. Also for consideration are some key words to keep in mind. Now on to Sam to talk about the methodology.
Thanks, Nanya. Prior to collecting data, we had a discussion on what data would be most useful and applicable for our report. We decided that we wanted to test our theory on two levels, a national one and a global one. With this in mind, we collected our global data from a website called Our World in Data. We were able to find data on a national scale from the National Center for Education Statistics. Although this data is from the United States, we decided to use it because of the valuable information it contained. This website did not have an easy way to compile the data, so we created a Python code that collected it for us. In its most basic sense, the code read the information on the web page and wrote it to a Google Sheet. At first, we collected the necessary data from every school district in the United States. However, this was simply too much data. We eventually decided to only use data from Texas, as Texas contains a good mix of urban and rural communities. Once we had collected all the necessary data, we manually removed any incomplete data points. We removed outliers by calculating the residuals and then calculating standard deviation. Any points that had a standard deviation of higher than 2 were removed. With all of our data ready to analyze, we had to decide the best way to analyze our data. We decided on a combination of Google Sheets and Python. We used Google Sheets to create our scatter plots and other visuals, and we used Python along with pandas, NumPy, and stats models to create our regressions. This is a sample section of what our code in Python looked like. These are our results for our global data. For this set of data, we've included the results of other lines to show that the fit we have may not be the best fit. The results for our high school graduation data contain slightly less information than the global data due to the more complicated nature of multilinear regression. Both the high school data and the post-secondary data results used other variables to make the results more precise. I'm going to pass it on to Isaac, who will further explain our data and its significance.
Thanks, Sam. Now that we have those values, it is vital we discuss the importance and meaning behind each calculation. This will be done using tests to examine correlation and tests examining data accuracy. This should give us an accurate measurement of what the data shows relationship-wise and whether or not it is an effective support. To begin, the worldwide dataset showed a reasonably strong correlation with an adjusted R-squared value of 0.668. This takes into account external variables that may influence the results and has been done to every data set to improve the likelihood of causation by isolating the external variables. This set also has a Spearman's rho value of 0.813 and a Pearson's value of 0.787, both of which support a reasonably strong correlation. This correlation can also be statistically significant due to a p-value smaller than 0.0001, invalidating the null hypothesis that the correlation between GDP and educational performance is insignificant. This will be our significance level for the remaining data sets. The accuracy of this analysis is supported by an extremely small standard error of 0.08 and a kurtosis and skew of 2.5 and negative 0.195 respectively, both of which are well within acceptable parameters. Taken together with the Durbin-Watson test, which yielded a value of 2.142, indicating little autocorrelation, which is positive in our conventional least squares analysis, this data set can be accepted as reasonably accurate. The next analysis was the post-secondary graduation rates as it related to income. The correlation here was slightly weaker than the global data set. However, this is to be expected when using a more concentrated sample. The adjusted R-squared value was 0.567, along with a Spearman's rho value of 0.6972 and a Pearson's value of 0.728, all of which confirm a moderate correlation. The null hypothesis in this case, that familial income does not affect post-secondary graduation, is disproven by a p-value smaller than the previously mentioned significance level, indicating high statistical significance. The accuracy of this analysis was then examined using the same statistical tests as before. Kurtosis and skew are acceptable at 2.432 and negative 0.002 respectively. However, both the Durbin-Watson test, yielding a value of 0.224, and standard error, yielding a value of 1.238, indicate that the dataset is not fully accurate, has positive autocorrelation, which is negative in our conventional least squares analysis. Taken together, we can understand that this dataset has a moderate statistically significant correlation with little outliers, indicated by minimal skew and kurtosis. However, it is not perfectly accurate due to the poor Durbin-Watson and standard error values. The third and final dataset analyzed was a comparison between income and high school graduation rates in Texas. The correlation here was seen to be much weaker than in previous datasets, with an adjusted squared value of just 0.402. This weaker correlation also has a lower Spearman rho value and Pearson value at 0.614 and 0.590 respectively. Despite this, however, the set remains statistically significant with a p-value below the significance level, disproving the null hypothesis that high school graduation rates are not dependent on income. The accuracy of these tests was then verified using the same test as before. An acceptable kurtosis and skew value of 2.77 and negative 0.338 were determined respectively. The standard error is still high at 1.076, but better than the previous dataset. This holds true when comparing the Durbin-Watson test value as well. This test yielded a value of 1.219, much closer to the optimal value of 2 than before. This dataset can said to be of a weak correlation, but a statistically significant one nonetheless, with moderate accuracy within the set. Taken together, these three datasets indicate that there is a reasonably strong statistical link between education and income, confirming the alternate hypothesis. Now, with an understanding of why a reasonable correlation exists between economic factors and educational quality, we can discuss and understand the implication of these findings. Our study accounted for 18 external factors which could influence our regression. This was the adjusted R-squared value mentioned previously. We use this strategy, so should a correlation be found, causation could be reasonably inferred. With this in mind, it is understood that as economic status increases, so too does educational quality. By acknowledging this correlation, it is reasonable to propose solutions which could assist in creating equity within the educational system. One method of doing this could be the implementation of a universal basic income. This would allow low-income families to have guaranteed support. Tests in Ontario indicate that this may be a viable option. Other solutions exist, however, this was picked as an example due to its Canadian relevance. The route to educational equity is different for every country, depending on what is socially acceptable. However, steps must be taken to correct the situation. Down to Nier with our sources of error and extensions.
Thank you, Isaac. Acknowledging error and sources of improvement and extension within reports is essential to advancing the knowledge within any given field. One of the first steps when performing any research or writing any report is reading background information on the topic to extend your understanding. To this end, Reflecting any report and considering changes or extensions is essential to ensuring that your report is beneficial and useful. Advised extensions would be the collection and analysis of more datasets to ensure universal application of the finding. Further research and analysis of various confounding variables would also be beneficial in confirming causation. This was done within our report, but more research would still be beneficial. In conclusion, we'd like to thank everyone who helped us on the way, including but not limited to STEM Fellowship project mentors, helpful teachers, and parents. In addition to that, we would like to mention our appreciation that the STEM program exists, allowing us to seize this opportunity. Thank you for listening to our report. We appreciate your consideration.